Now there are various patterns which connect the square numbers. So let's see the different patterns which we can construct from the square numbers which we have already discussed in the previous sessions. So we all know that the square numbers starting with 1 square is 1, and then starting with the next square number is 2 square, which is 4, but 4 I can write it as 1 plus 3. So let me just identify a pattern by splitting 4 as 1 and 3. So sum of 1 and 3 gives me 4. So 2 square is 4, which I can equally write as 1 plus 3. Next, I have 3 square, which is 9. The square of 3 is 9. And this instead, I can write it as, I would like to split 9 as 1 plus 3 plus 5. So coming to this, my next square number is 16, which I can split as 1 plus 3 plus 5 plus 7, 10, 17, 8, 9, 16. So I can find a pattern in the right hand side. As I start proceeding downwards, I identify that it is sum of all the odd numbers when you take square of each number. So my 5 square blindly would be 25, which is nothing but 1 plus 3 plus 5 plus 7 plus 9, as can be verified when randomly added. This would be 25. So this is how I identify the pattern connecting the square numbers and the sum of odd numbers. So in this case, I just observe that when the pattern proceeds this way, then each of the terms, the number of terms when there is 2 square would be 2 terms matching with the base number. Now because the base number here is 3, the number of terms here is 3, and here the base number is 4, the number of terms here will be 4. The base number is 5, so the number of terms is 5. How many terms do I have here? Because the base number is 17, I need to have 17 odd numbers which are added to get to 89. So without any addition or splitting, I randomly write this 17 odd numbers starting with 1, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then 31 and 35. So these are the set of numbers which when added from the odd numbers starting with 1 and 35 would give me 289. Because of the base number being 17, I have exactly 17 numbers which are added here, starting with 1 and ending with 35. So this is how I understand the square numbers connected with the pattern. Now how do I understand this geometrically? If I wanted to understand this geometrically, then how do I do that? So how do I geometrically understand 2 square is 4, which is 1 plus 3? We have already dealt with 2 square being 4 with the square number, as I have seen here. With 1 square it is 1 square, but with 2 square it is a square split into 2 units. Then I understand that here it is splitting of 1 and 3, which is indirectly nothing but splitting of area of square, which is 2 square, and this is 4, which is nothing but 1 plus 1, 2, 3. So this is 1 plus 3. So this is how I understand the square connected to the square numbers in the pattern 1 plus 3. So let me take 3 by 3. In this case, the first is, and the second, as I go in the L-shaped format, is this, and then I have the different patterns. So in this case, I identify that there are 3 different patterns which are constructed here. Therefore, in this case, the area of square is with 3 units. Therefore, it is 3 square and it is 9. The 9 which is split is 1, 1, 2, 3. So I have this 1, 1, 2, 3, and this is 1, 2, 3, 4, 5. So I find a pattern where this 9 can be split as 1 plus 3 plus 5, going by each one, 1 plus 3 plus 5. So when I connect this geometrically to this, I understand that the area of square is very much which gives the pattern in the square formats taken in blocks, and similarly it can also be through the pattern which I identify here. So geometrically I understand through squares, and analytically I just understand by randomly adding and observing a pattern, and this very much holds for any number of values taken into consideration, and that is what is the pattern connecting to the square numbers. So every square number can be written as sum of odd numbers, consecutive odd numbers. This is how we do that. So going by the pattern, I see that the sum of first 3 odd numbers is 3 square, and sum of first 5 odd numbers is 5 square, and the sum of first 4 odd numbers is 4 square, and the sum of first 17 odd numbers is 17 square. Therefore, sum of first n odd numbers will be n square. So let's come to a conclusion in general pattern of n, which says that for n, sum of first n odd numbers will be n square. So this is a formula which has been generated from connecting the patterns to the square numbers. So the sum of first n odd numbers will be n square, irrespective of what n is. So n depends on each of the topic taken into consideration. So finally we conclude that sum of first n odd numbers is n square. As we see the second type of patterns connected to square numbers, so we'll see how the second method, the second type of patterns which are identified in square numbers are clearly going to be described here. Now, as I start with 11 square, we all know that 11 times 11 is 121, and then if I just take 101 whole square, this is 10201, as you can just multiply here 10100. So this is 10201 which I get. So interestingly, I find that if the number of zeros here will be the number of zeros on the left and right, and this 2 will always be fixed. That is, when I take the pattern 1001 whole square, then this follows the similar pattern as the case of this. For example, I have 101 which is written as 10201. So 1001 is written as 100 because 10 followed with 10 here. So 2 zeros are followed with 2 zeros here. This 2 is always fixed and then followed with 2 zeros and 1 on the right. So this is how I get when I multiply. We can just randomly check that this will be always this. So coming to the next, if I have 3 zeros in the middle, then square of this would be 1, 3 zeros followed with 2, then 3 zeros followed with 1. So this will be the value. So coming to the next, if I have 4 zeros in the way, whole square would give me 4 zeros followed with 2, then 4 zeros followed with 1. So this is how I get the square of these particular numbers. So if I just wanted to find 1, 2, 3, 4, 5, 6, 7 of 1 whole square, then I have 7 zeros on the left of 2 and 7 zeros on the right of 2, and then the value becomes 7 zeros. 1, 2, 3, 4, 5, 6, 7, 2, 1, 2, 3, 4, 5, 6, 7, 1. So this is how I identify the pattern in case of the numbers which are in the form of 101, 1001, 10,001, 1 lakh and 1, 1 crore and 1, and etc. So this is how the pattern is identified. Next, The third pattern I identify in case of the square numbers connected to the patterns, the various patterns, is that if I just again revisit 11 squared is 121, and if I take 111 whole square, so let me multiply and see what I get exactly. So I get 1, 2, 3, 2, 1. So I got the value as 1, 2, 3, 2, 1. Then I get 1, 2. If I just square the four numbers, then if I have the number of digits which are 1 here are 2, the number of digits which are 1 are 3, the number of digits which are 1 are 4. So in this case I got 1, 2, 3, then 2, 1, where I am going in the reverse way, increasing and then decreasing. So if I have 4 ones, I have the number starting with 4, increasing till 4 and then decreasing till 4. So similarly, if I just have 5 ones which are squared, then in this case I increase from 1 to 5 and then from 5 to 1. So that this becomes 1, 2, 3, 4, 5, 4, 3, 2, 1. So this is how the construction happens. If I wanted to find whole square, I just count the number of ones, which are 1, 2, 3, 4, 5, 6, 7, 8, 9. Because there are 9 ones, so I have to write the numbers till 9. 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. So this is how I increase till 9 and then decrease until it reaches 1. So this will be the value which can be verified by randomly multiplying. So this is one more type of pattern which is identified connecting to square numbers. But interestingly, in case of third type, note, there is interesting note which I make. The numbers, when you take from starting, it is 1, 2, 1, but when you read from the last are also equally 1, 2, 1, 1, 2, 3, 2, 1 and 1, 2, 3, 2, 1. The numbers which are read from forward and backward are same, are called palindrome numbers. So the above numbers read the same from forward and backward. They read the same from forward and backward. Therefore, these numbers are called palindrome numbers. So these are called the palindrome numbers. Now in this fourth pattern, I identify that square of an odd number has been identified with some pattern. So let's see what kind of a pattern is identified for square numbers which include the odd numbers. Say for any odd number, I take, say, for starting with 3 square. I cannot take 2 square because 2 is not an odd number, it's an even number. So the first odd number I take into consideration is 3 square, which is 9. So we all know that the square of 3 is 9. This can be split as 4 plus 5. I always split with the middle term. Now the middle term here is either 4 or 5. Therefore, I split as 4 plus 5, which is nothing but 9. So this is understood to be 4 can be written as 3 square minus 1 by 2. And this can be written as 3 square plus 1 by 2, as can be simplified. I can clearly see that this is 9 minus 1, which is 8. 8 by 2 is 4. This is 9 plus 1, which is 10 by 2, which is 5. So I can split this 3 square in the form of 3 square minus 1 by 2 plus 3 square plus 1 by 2. So this is the pattern I identify in case of the odd number, which when squared gives me this kind of a pattern. So let's see if this holds true for even the next odd number. Now let me take the next odd number, which is 5 square, can be written as 25. I can write 25 as 12 plus 13 if I split along the middle term. Now clearly I see that 12, I can write this as 5 squared minus 1 by 2, and this 13 can be written as 5 squared plus 1 by 2. As I can see here, this is 5 square is 25. 25 minus 1 is 24 divided by 2, when cancelled with 2 gives me 12, which is exactly the same. So that I can write this term as 5 square minus 1 by 2. Similarly, 13, I can write it as 5 square plus 1 by 2, because 5 square is 25 plus 1, which is 26, divided by 2. 2 ones, 2 13s is 13. So this also follows a pattern which I can identify from 3 and 5. So clearly, going by this, I understand that if I take 289, I can split this. 17 square is 289. I can split this as 144 plus 145, which directly can be written as 17 square minus 1 by 2 plus 17 square plus 1 by 2. So as simplified can clearly give me the value, as you can verify, cross-check from the simplification process on the right hand side. So using with this above patterns, I make a conclusion that for n odd, for any odd number which is squared, I get a pattern in this form. Therefore, for general n as an odd number, I get that n square can be written as n square minus 1 by 2 plus n square plus 1 by 2, as has been seen in various cases of different odd numbers taken as the square numbers. So this is the general pattern. I identify that for n, for any odd number n, n square can be written as n square minus 1 by 2 plus n square plus 1 by 2, which on simplification gives nothing but n square. It is nothing but the LCM, and then cancelling of the terms and further simplification gives me n square back again. Now let's see the Pythagorean triplets which are part of the square numbers. So Pythagorean triplets are identified using the square numbers. They are very much connected to the square numbers, which we already discussed in the previous session. Now Pythagorean triplets satisfy the condition if suppose I have c square equal to a square plus b square, the square number, the square of c is equal to sum of square of a square, a and b, then in this case a, b, c are said to be called Pythagorean triplets. So these three are called Pythagorean triplets if they satisfy the condition c square is equal to a square plus b square. If we recap, we know that this is very much connected to the right angle triangle where the Pythagoras theorem is used, where the c is this and a is this and b is this. So whatever comes on the left hand side will be the longest or the highest value out of this. So it is a very important note that if suppose I have c square equal to a square plus b square, then c is the highest value of all three values. So whatever comes on the left hand side as independent other than the sum of squares, that value will be the highest value of a, b, c. So whenever we identify the Pythagorean triplets, we first identify the highest value out of the three given values. That we discuss more clearly in the next coming sessions of the problems. So c is the highest value of a, b, c, very much connected to the right angle triangle. If c square is not equal to a square plus b square, then we say that a, b, c are not Pythagorean triplets. For Pythagorean triplets, the most important condition is that sum of squares of the other two sides should be equal to square of one of the side. That is, c square should be equal to a square plus b square. Then only a, b, c form Pythagorean triplets. And next, generally Pythagorean triplet is denoted with a bracket put in this. So if I write in the form a, b, c in brackets, then this is called the Pythagorean triplet of a, b, c. That means these three form a Pythagorean triplet when put in bracket. So this is the symbol I use for Pythagorean triplet. Say for example 3, 4, 5. So coming to the example, I just wanted to know whether these three form a Pythagorean triplet or do not form a Pythagorean triplet. So let's see how we are going to process in a stepwise proceeding. Now, the first and foremost step in identifying the Pythagorean triplets is we select the highest value. Now, in case of 3, 4, 5, I identify that 5 is the highest value. So, my highest value is 5. So, this highest value will decide the Pythagorean triplets. So, as continued from the example where I had to find whether the numbers 3, 4, 5 form a Pythagorean triplet, I identify that the highest value in that case is 5. So out of these three numbers, 5 being the highest value, I just square on the left hand side. This is identified as C. So this is identified as C. Therefore, my C square, which is 5 square, is 25. Then I square the other two sides, which is 3 square plus 4 square, which gives me a square plus b square, which gives me 3 square plus 4 square, when on further simplification gives me 9 plus 16, which on adding gives me 25. So as I see between this 25 and this 25, clearly c square is equal to a square plus b square. That is, my c square is 5 square equal to 3 square plus 4 square. Therefore, I clearly identify that in this case, this forms a Pythagorean triplet. Therefore, 3, 4, 5 form a Pythagorean triplet because they satisfy the condition c square equal to a square plus b square. Therefore, 3, 4, 5 form a Pythagorean triplet. So any problem, we first select the highest value and then square it, and then take the other two values, square and add, and then if those two are equal, then we say they form a Pythagorean triplet. So let's see another problem where we just test for the Pythagorean triplet and then justify whether the given triplet forms a Pythagorean triplet or not a Pythagorean triplet. Say I have three numbers 11, 12 and 15. So I wanted to find whether they form a Pythagorean triplet. So let's take the highest value. Now the highest value here is 15. So in case of this problem, I identify that the highest value is 15. So let's take it as c square. So c square is 15 square, which is 225. Now similarly, I would like to square the other two values and then sum up. So in this case, a square plus b square would be the other two squares added, 11 square plus 12 square. Now when I just square and add them, these two square numbers lead to 11 square giving me 121 and 12 square giving me 144. So once I get this, let me add up, then I think I get this as 265. But clearly I identify that this is not equal to the value which I have identified here. So therefore, because it doesn't satisfy the condition, therefore a square plus b square is not equal to c square. Clearly I identify that the given three values 11, 12, 15 do not form a Pythagorean triplet. That is, in this case, 11 square plus 12 square is not equal to 15 square. Therefore, because of this condition not being satisfied, the 11, 12, 15 do not form a Pythagorean triplet. So that is how we decide on how they form a Pythagorean triplet or do not form a Pythagorean triplet. So any bigger values given in the problem, we can easily identify them for being a Pythagorean triplet or not using the concept of squaring and just using the formula c square equal to a square plus b square. Now, how do you connect this? If I take this problem, how do I connect this to geometrical concept of understanding? It is very simple. as I know that Pythagoras theorem is very much related to the right angle triangle, I take a right angle triangle and then I take the highest side. So in this case, because it doesn't form a Pythagorean triplet, I cannot use this for a right angle triangle. So I take the previous problem where I understand that phi is the highest value, which is always on the hypotenuse of the right angle triangle, and the other three being 3 and 4 are just taken on the either sides. So I understand that when three values form a Pythagorean triplet, they exactly fit into the dimensions of a right angle triangle. This is how I understand. So the note here says that ABC form a Pythagorean triplet implies ABC exactly fit as dimensions of right angled triangle. So if ABC form a Pythagorean triplet, they exactly fit as dimensions of right angle triangle. Of course, C being its hypotenuse and A and B being the other two sides, which include the right angle. So this is how I geometrically understand between algebraically understanding the Pythagorean triplets and connecting them to the geometrical concept. So finally I conclude that when ABC form a Pythagorean triplet, they exactly fit into the right angle triangle, with its highest value always being the hypotenuse of a right angle triangle and the other two values being the other two adjacent sides, including the right angle. So now that we have discussed about square numbers, we will also discuss about the square roots. The actual topic is square roots and cube roots. So we are entering into the actual topic of square roots. So we'll see how square numbers are connected with square roots and its independent definition. So let's see the definition of square roots and then start with few examples to understand the topic more better. So square root is defined as, now before I define the square root, I just give you the symbol. Square root is denoted by this. So this is how I denote the square root. So if I say square root of A, it is square root of A. If I say square root of X, it is square root of X. If I say square root of 4, it is square root of 4, which is written this way. So this makes me understand that it is square root of A. That is example, if I write square root of A, that means this is read as square root of A. So this is read as square root of A with the symbol root of A. Yeah. Now with this definition, the square root defines that if I have square root of A square will always be A. This is the definition of a square root. Very important. So square root of a square number is its base. So whenever I have a square number, this base will be the answer for square root. So for example, using the definition, if I wanted to find square root of 4, so I have to express this as a square number and then the base will form the answer for the given problem. So let's see how I can express 4 as the square number, which we already done in the previous sessions. So 4 can be written as 2 square, which is nothing but in the form root A square, which is A. So using this formula, I get root of 2 square is 2. So this is the answer. Therefore, square root of 4 is 2. This is the answer. So let's take one more example. Square root of 49. So I'll express 49 as the square number, which is nothing but 7 square. So the square number 7 square is 49. Therefore, by the definition of root A square is A, I get this to be 7. Therefore, square root of 49 is 7. So this is the answer. So this is how I understand the square roots for each of the examples.